In this lesson, you will learn to determine the least common multiple of two numbers, the greatest common factor of two numbers, and how to determine if a number is prime or composite. So first off, we're going to talk about multiples. A multiple is found by multiplying a number by some other number. So for example, if I said list the multiples of 6, the multiples of 6 are found by doing 6 times 1, and then 6 times 2, 6 times 3, 6 times 4, etc. So that would be 6, 12, 18, 24, 30, and that would keep going forever. So that is what we mean when we say multiples of something. So we see here listed the multiples of 6, 6, 12, 18, 24, 30, 36, etc. So you can think of it as counting by sixes. If I said to list the multiples of the number 8, what would those be? Well, again, we can take the number 8, multiply it by 1, and multiply by 2, multiply by 3, etc. That would give you 8, 16, 24, 32, 40. That would keep going forever, and that would be the multiples of 8. So again, it's going to be found by multiplying by different numbers. Okay, or in other words, in this case, we can count by 8. All right, so that's how multiples work. And so if you look at these two lists of multiples of 6 and 8, notice that there are some that they have in common. All right, so notice they have a 24 in common. So they both have 24. And then notice they both have a 48 in common. So they have multiples in common. And this would keep going. They would have more multiples than just that. It would keep going forever and ever, having common multiples. So the common multiples of 6 and 8 would be 24, 48, etc. Now the smallest or the least common multiple is going to be the number 24. And this is going to be important as you progress in your study of math. The least common multiple is used in many different areas. One area specifically is dealing with fractions. You're trying to add and subtract fractions. At some point, you're going to have to know how to find that least common multiple. All right, so the least common multiple, or it can be abbreviated as LCM, of 6 and 8 would be 24. So that is how multiples work. And then we have what's called factors. So if I said, what are the factors of 20? Okay, what this means is what numbers would multiply to give you 20. All right, so think through the number 20. What can we multiply together to equal 20? Well, 20 could equal 1 times 20, or it could be 2 times 10, or it could be 4 times 5. So the factors of 20 would be any of those 6 numbers that we see here. It could be 1, it could be 2, 4, 5, 10, or 20. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And by the way, this little symbol right here with the 3 dots, that just means therefore. So therefore, the factors of 20 are 1, 2, 4, 5, 10, and 20. Now why don't you try the next one? What are the factors of 24? Well, the factors of 24, again, are found by seeing what numbers can multiply together to give you 24. So to get 24, we could do 1 times 24. We could also do 2 times 12. We could do 3 times 8, or we could do 4 times 6. So therefore, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So those are the factors of 20 and the factors of 24. And notice here they have common factors. So they both have 1 in common, they both have 2's in common, and they both have 4 in common. So those are common factors of 20 and 24. And the greatest common factor the greatest one, or the biggest number in common, is the number 4. And that number, the greatest common factor, is very important as we progress in our study of math. It is used for many different things, a lot of which is kind of beyond your capabilities now, but you can trust me that in the future you will use greatest common factor a lot. Alright, so that's how factors work. And now to finish off, we want to understand the difference between prime and composite numbers. And prime and composite numbers, to understand the difference, you had to understand how factors work. So prime numbers has only 2 factors. It has only 1 and itself. We'll give you some examples in a moment. Composite numbers has more than 2 factors. So if it's not prime, it's going to be composite. Alright, so what are some examples of prime numbers? Well, let's start with the smallest number that we can begin with. So 1 is neither prime nor composite, but then we start with 2. Okay? So you try to figure this out on your own as we go through some of these numbers. See what you can, see if you can figure out the solution. Is it prime or composite? So 2 has factors of 1 and 2, right? You can do 1 times 2. There's no other factors to get 2, right? So because there's only one set of factors, it's only the number 1 and the number 2. Because of that, the number 2 is going to be prime. Now what about the number 3? Well, 3, the only way to get 3 is doing 1 times 3. There's no other factors other than 1 and itself, 1 and the number 3. So for that reason, 3 would also be prime. Now what about the number 4? Is 4 prime or composite? Well, 4, you can get 4 by doing 1 times 4, but you can also do 2 times 2. So because it has the other set of factors of 2, because of that, this number 4 is going to be composite. Now let's try the next number. We'll try 5. See if you can get this on your own. Is 5 prime or composite? Well, 5 would be prime because the only way to get 5 is by doing 1 times 5. So 5 would be prime. Let's try the number 6. Is 6 prime or composite? Well, 6 we can get by doing 1 times 6, but we can also do 2 times 3. So the factors of 6 would be 1, 2, 3, and 6. And because we have the other set of factors, so because we have 2 times 3 as factors, that would make 6 to be composite because it has more than just the 2 factors of 1 and itself. Alright, so hopefully you're catching on with this. We'll do a few more just for practice and see if you can get these on your own the best you can. So let's try the number 7. Is 7 prime or composite? Well, to get 7, we would do 1 times 7, and that's the only way to get 7, right? There's no other way to multiply numbers to get 7, so this would be prime. What about 8? Is 8 prime or composite? Well, to get 8, we could do 1 times 8, but we could also do 2 times 4. So because we have this other set of factors, we have the 2 and the 4, because of that second set of factors, this number 8 would be composite. Alright, so 8 is composite. Alright, what about 9? Well, 9, we can do 1 times 9, but we can also do 3 times 3. So again, because we have 3 times 3, we have the second set of factors, so we have not only the 1 times 9, but also 3 times 3. That makes the number 9 composite. Okay, what about 10? Well, 10 could be 1 times 10, but we can also do 2 times 5. So again, we have 2 sets of factors, so we have more than 1 set of factors, so that would make the number 10 to be composite. And this can keep going on forever and ever. You can do this for any set of numbers. We just did the numbers 2 through 10. Let's try one more. We'll just make up a number, see if you can do this on your own, and then this will conclude our lesson for today. Okay, what if I gave you the number, let's do 24. Is 24 prime or composite? Hopefully you got this correct. So 24 would be composite. The reason is because we have 1 times 24, but we also have 2 times 12, we have 3 times 8, we have 4 times 6. We have all these other factors other than just 1 in itself. So because of that, the number 24 would be composite. Alright, so in this lesson, you've learned how to find the least common multiple. You've learned about factors and how to find the greatest common factor. We've also used factors to help us determine if a number is prime or composite. And that concludes our lesson for today. We will see you next time.